Okay, we are still in this Ferris wheel question. I've copied everything from the previous video onto here. The graph, kind of a breakdown of the diagram that we have. And what we want to do now is write an expression, an equation, which expresses our height as a function of the elapsed time. So starting from 0, where are we going to be in the cycle? Now, if you recall, I can use any trig equation, sine or cosine, to model this motion. But usually one is the most appropriate. I don't know if you recall, there's y equals sine x, which starts from the middle, goes up, down, up. I have y equals negative sine x, which starts from the middle, goes down, up, down. I have y equals cos x, which starts from the top, goes down and up. And I have y equals negative cos x, which starts from the bottom, up, down. Any one of these is fine, but I want to choose the one that will not have any kind of horizontal shift. And if you look at all these, 4 examples here, and then the graph that we have under consideration, notice how it starts at the bottom, goes up, comes down. Well, which of the 4 does that match in terms of a pattern? And it's clear that it's the negative cosine. Negative cosine starts at the bottom, goes up, and then back down. This graph starts at the bottom, goes up, and then back down. Obviously, it makes sense because that's where we get on. Okay, it starts going up, halfway point here, comes to the top, which is up here, and then comes back down, yada yada. So of these 4, I'm going to first of all erase these 3 because this is the guy that I'm going to be using, okay, as my template. What do I mean by that? Well, the equation is going to be y equals a, which is my amplitude, times, negative a because it's negative cosine. Cosine, I'm going to have my b value, and I'm not going to have any horizontal shift, so I don't have to write in x minus h already because there's no shift over here. Okay, it's just going to stay as it is, which simplifies my equation. So I'll just have bx and then a plus k over here. So what can I write into my equation? Well, my amplitude. Remember, that's the distance, and let's use a red. That's the distance from the middle to the top or the bottom. In this case, it's going to be 30. Another way to think about it is that it's the radius of the Ferris wheel. And I can rewrite my equation as, let me just actually cut and paste this. I'm just going to replace the a with 30, negative 30, because it's opening down. Next is my b value, which is related to the period, or I guess 1 full revolution. So b is going to be 360 divided by 80, which is going to give me 9 over 2. So I can take this. Oops, I want to copy that. Over here, replace my b value by 9 over 2. Finally, I have my k value, my middle, and my graph is a little bit off, but that 31 is my middle point, or my sinusoidal axis, and that's what's going to replace my k here at the very end. So there's your equation. Okay, nice and simple because there's no phase shift going on, so we don't have to solve for an h value. For the height, given some time t, and by the way, I've used x as my variable. I do have a t here, so technically, to be consistent, let me put this up here. My equation should be me just take all of this. Get rid of this border here. Oops. And just replace the x with a t value. And also, by the way, the y, which is our height, you know, I've been using, I think I had h. Whatever. Let's just put h here. H here. And if you want to make it explicit, the dependency on t, you can write it as a function, h of t maps to here. Whatever you want. Anyway, there's our equation modeling the height of the passenger on the Ferris wheel.